Hello, everyone. Welcome to the mini lecture on electromechanical control technology. In this lesson, we will learn about the parameters of motion control cards. Our lesson will cover the following 4 main topics. Through this lesson, you should be able to understand the key parameters of motion control cards, including hardware interfaces, control accuracy, control modes, and communication protocols. Learn how to describe the meaning and importance of these parameters. Based on specific application scenarios, for example, CNC machines, automated production lines, learn how to select the appropriate motion control card model based on its parameters. Today's focus will be on an important aspect of motion control cards: parameters. These parameters not only serve as the foundation for selecting and using motion control cards, but they are also crucial for achieving precise control. Let's begin with the first part of today's lesson: overview of motion control card parameters. The parameters of motion control cards refer to key indicators that describe their performance, functionality, and applicable scenarios. These parameters typically include hardware interfaces, control accuracy, control modes, and communication protocols. By understanding these parameters, we can better select and use motion control cards to meet the specific needs of applications. 2. Detailed explanation of key parameters of motion control cards. 1. Hardware interfaces. The hardware interface of a motion control card determines which external devices, such as motor drivers and sensors, it can connect to. Common hardware interfaces include pulse output, analog output, and digital input-output. When selecting a motion control card, it is necessary to choose an appropriate hardware interface based on the types of external devices. 2. Control accuracy. Control accuracy is a crucial parameter for motion control cards, as it determines the smallest movement unit achievable by the motor. Control accuracy is usually represented by pulse equivalent, the distance the motor moves per pulse. When selecting a motion control card, choose the appropriate model based on the required control accuracy for the application scenario. 3. Control modes. Motion control cards typically support multiple control modes, such as position control, speed control, and torque control. Different control modes are suitable for different application scenarios. For example, in scenarios requiring precise position control mode should be selected. For smooth speed control mode should be chosen. 4. Communication protocol. The communication protocol is the standard for data transmission between the motion control card and the host computer. Common communication protocols include RS-232, RS-485, and Ethernet. When selecting a motion control card, ensure that the communication protocol is compatible with the host computer's interface and the supported protocol. 5. Other parameters. In addition to the key parameters mentioned above, motion control cards may have other parameters, such as the maximum number of controlled axes, maximum pulse frequency, and maximum output current. These parameters should also be considered when selecting and using motion control cards. 3. Impact of motion control card parameters on performance. After understanding the parameters, let's discuss how these parameters affect performance. 1. Hardware interface and compatibility. The selection of hardware interfaces directly affects the compatibility of the motion control card with external devices. If the interface does not match, it will result in failure to connect or communication errors. 2. Control accuracy and positioning ability. The higher the control accuracy, the better the positioning ability of the motor. This is especially important for applications requiring high-precision positioning. 3. Control modes and flexibility. A motion control card supporting multiple control modes can adapt to a wider range of application scenarios, increasing the system's flexibility and adaptability. 4. Communication protocol and data transmission efficiency. Efficient communication protocols improve data transmission efficiency and stability, ensuring real-time communication between the motion control card and the host computer. 4. How to select the right motion control card based on application scenarios. When selecting a motion control card, we need to tailor the choice based on the requirements of the application scenario. Here are some suggestions. 1. Clarify the application scenario. First, define the application's requirements for the motion control card, such as control accuracy, control mode, and communication protocol. 2. Compare different models. Based on the application requirements, compare the parameters and performance of different motion control card models and select the most suitable one. 3. Consider cost effectiveness. In selecting a motion control card, consider cost effectiveness. Choose the model with the best value for money while ensuring that performance meets the requirements. The significance of setting motion control card parameters lies in ensuring the precision, stability, safety, and flexibility of the motion control system, while also improving energy efficiency and facilitating debugging and maintenance. This is crucial for enhancing the overall performance of equipment and operational efficiency in enterprises. Lastly, please think about this lesson and complete the following exercises to consolidate today's knowledge points and deepen your understanding. That concludes our lesson for today. See you in the next lesson.